Thank you so much for watching our video about memory characterization. This is a project sponsored by GE Aviation and completed by Grand Valley State University students. We'd love for you to meet our team. I'm Abigail Hendrick, the team captain. I'm also working with the wonderful Charlie Dorn, Nick Behrens, Nick Bernhardt, and Zach Hales. Here's the situation. At high altitudes, high-energy particles strike circuits, and this causes the circuits to change and mold into different things that we don't particularly want. These especially affect memory components, such as DDR, flash, etc. These are single event effects, and they are bad. Here's our problem. We need to make one of these, a circuit board, a lot like the little green boards you see in other components or other electrical items. These are called circuit card assemblies, or CCAs. This board needs to detect single event effects, those bad effects caused by high energy particles. We also need to report on temperature, circuit status, and other details about the CCA. Here are our requirements. We need to design multiple of the CCAs with a processor, a heater and temperature sensor, power regulation, and a current sensor. We also need to design software that allows the user to set pertinent variables and periodically updates the user on the peripheral and the status of the memory device that we are testing. The solution that we came up with is called MEMZAP. We tested this solution by buying an Ultra 96 development board. Then we designed our own board. And finally, we built the board and added all of the components necessary by soldering. In the end, our software interfaced with this board, and we were able to test memory components and see how exactly they interact when they're exposed to high energy particles. Eventually, this board will be taken to a lab and placed inside of a high energy beam chamber. This will be hidden behind a 7-foot concrete wall, and the beam will be directed at the DUT, or device under test. Our software will then run behind the 7-foot concrete wall and show the user exactly how those high energy particles were affecting the memory. Thank you so much for watching. I hope you enjoyed learning about our solution MEMZAP.